So this section is going to talk about something called the rational zero theorem. What the rational zero theorem tells us is that if p of x is a polynomial function with all integer coefficients, then every rational zero of p of x is equal to 0. It's of the form p over q, where p is a factor of the constant and q is a factor of the leading coefficient. So those words, a lot of words, can get a little confusing very quickly. So what you basically do is that when they're asked to list all of the possible rational zeros, p is your constant, q is your leading coefficient. And what you're going to do is you're going to say, all right, I need to make p over q. Well, p I said was 4, q I said was 3. Now, what makes 4? Well, 1 and 4, or 2 and 2. So I'm going to do plus or minus 1, plus or minus 2, and plus or minus 4. Those are all the different factors that would make up 4. The plus or minus component needs to be there, so please make sure that you write those. Now for 3, 3 is prime. So we only need 1 and 3. And when we say all possible, that means every combination. So you're going to basically put each number over the other. So if I start with 1 in the numerator and put it over 1, I get plus or minus 1. If I put 1 over 3, I get plus or minus 1/3. Now I jump to 2. 2 over 1 is 2. 2 over 3 is 2/3. 4 over 1 is 4. 4 over 3 is 4/3. So those are all possible rational zeros. Not saying they are all the zeros, but those are all possible. So for b, p would be 15, and q in this case is 1. So p over q, p is 15, q is 1. So what makes 15? Well, that would be 1, 3, 5, and 15. What makes 1 would be 1. So this one's nice and easy. 1 doesn't affect anything, so you just recopy the numerator values down. Okay. So here's a practice one. So p is 10, q is 7. Just always make sure that they're in the correct order. So if we have 10 over 7, well, what makes 10? That's 1, 2, 5, and 10. And then 1 and 7 make 7. So now we make all our combinations. So 1 goes over everything, so 1 and 1/7. 2 goes over